In the previous video, we learned how Swift utilizes implicit bridging to work with the Cocoa framework. In this video, we're going to see how we've already been exposing our Swift code to Objective-C. Then, we'll create an Objective-C project and call some Swift code from Objective-C. Assuming that you've been working in Swift for a little while, you've been exposing bits of your Swift code to Objective-C all along. For example, if you've ever utilized an IB outlet or an IB action or NS managed, you've been working with Objective-C. Furthermore, if you have a class that is a subclass of NS object, then by default, the entire class is exposed to Objective-C. In this example, we see a familiar class that subclasses UIViewController, which indirectly subclasses NS object. So these NS object methods and properties will be exposed to Objective-C. However, functions and properties that use Swift-only features will automatically be ignored by Objective-C. Of course, you can limit your properties' visibility to just Objective-C by labeling them as private, which will make them visible only to the containing class. To more deliberately expose your code to Objective-C, you can utilize the @obc keyword on your properties and methods. On the other hand, you can also use the non-obc modifier to limit your code's visibility to Swift only. Let's create a simple Objective-C application that runs some Swift code. Open up Xcode and create a new project. Choose iOS Application and Single View Application. Name it anything you like and make sure you change your language to Objective-C. Click Next and then create your project. Let's start by adding a Swift file to our application. Click on your root directory and press Command-N. Select iOS Source and choose Cocoa Touch class and click Next. Name your class Hello from Swift and add a subclass of NS object. We'll select Swift as a language and then click Next and then Create. You'll be prompted with a dialog asking if you'd like to create a bridging header. Click Don't Create. We're not going to be working with the bridging header manually because Xcode will generate an umbrella bridging header for us. All we need to know is how to import the generated header, which we'll do momentarily. In your Swift file, name your class Hello from Swift. We'll create a variable named message and give it a default value of from Swift. Next, we'll create two initializers, one override initializer that calls superinit, and one required initializer for our NSObject class, which also calls superinit. Finally, we'll add a method named getMessage that simply returns our message variable. There are a few build settings we need to change before we start with our Objective-C code. Click on your root project and select your application under Targets, and then select Build Settings. In the search bar, search for Embedded Content Contains Swift Code and set it to Yes. Then, search for Install Objective-C Compatibility Header and set it to Yes as well. Finally, search for Defines Module and set that to Yes. Now that we have our build settings in order, let's open viewcontroller.m and call our Swift code. At the top of your class, an import statement for our auto-generated bridging header. The auto-generated header starts with your project name, then a hyphen, then swift.h. Now let's create a class instance. Right away we're getting errors. While NSObject makes Swift available to Objective-C, our Swift class inherits an access modifier of internal, which makes it invisible to Objective-C. Let's mark our class, variable, and function as public. And we see our class instance is now valid. Let's try printing our message variable to our console. Declare an NSString variable and name it message and set it equal to hello.message. Let's use an NSLog to log it to the console. Build and run, and we see our Swift message print to the console. Again, if we change our access modifiers on our variables to private, we lose the ability to call that variable directly from Objective-C. We can still print our message, though, by calling our Swift function. Let's change the value assignment to our variable from hello message to hello get message. Build and run your application, and again, our message prints to the console. In this video, we have successfully called Swift code from Objective-C. In the next video, we'll see how to call Objective-C code from Swift.